All right, now we're going to cover 12.5, volume of pyramids and cones. All right, the volume of a pyramid. It's the same as a prism with the same base, only you're going to multiply it times a third. So this is totally different than surface area, right? You take the area of the base and multiply it times the height times 1/3, right? If we took a prism with this base and put it up here, and then we calculated its volume, and then we did this pyramid with the same height, but as a pyramid, if we fill them up with water, this would fill up 1/3 of the water that the prism does. Okay, it's just that's just the way it works on pyramids. Same thing on cone. The volume of a cone is 1/3 the area of the circular base times the height. So the only difference between these formulas and the ones before is you're putting a third in front. All right, any questions? Everybody has it. Okay. Find the volume of the solid. Okay, it's got a triangular base, height of 9. Make sure on the height it's the perpendicular distance. Okay, and we need to find its volume. So we would do volume equals 1/3 the area of the base times the height. So it's going to equal to 1/3 times 1/2 base times height times big H. So that's going to be 1/3 times 1/2 times the area of the base. So that'd be 6 times 9 times the height is 9. So 4 times 9 equals 36 meters cubed. Did you mow grass this morning, Seth? Last night? You might want to pound your shoes off before you come in class. Get grass all over my floor. All right. Any questions on that? Okay. So let's clear that out. Let's do the cone. Volume of the cone equals 1/3 area of the base times the height. The base is a circle, so it's going to be 1/3 times pi r squared times h. So that's going to be 1/3 pi. The radius is 2.2 squared times the height is 4.5. All right, so we calculate all that. Let's see if we calculated that, what we'd get here. So we did there was the first one, 36, and here we've got plug in, and we get 7.26 pi, and that's centimeters. They didn't label the units; it'd be centimeters cubed. Make sure you put the correct units. You'll get a small penalty. You'll get a half off or something if you just put squared or whatever, or just meters. It has to be cubed. I'm talking about cubic units. Any questions here? Okay. So it works out to be 22.81 centimeters cubed. Everybody got it? Alright, here's another problem. Originally the pyramid had a height of 144 meters and a volume of 2 million some odd cubic meters. Find the length of the side of the square base. Okay? Length of the side of the square base. So let's draw a picture of a square pyramid. Alright, it's got a square base. Length S. So it's S by S. The height is 144. And the volume is given. Okay? So we're still going to use the formula V equals 1/3 big B times H. We're going to plug in what we know. We know the volume. The volume is 2,226,450. That's going to equal 1/3. The base, what's the area of the base of a square? What would it be? We don't have numbers, but what would it be? What formula would it be? What? Side squared, yeah, S times S. So 1/3 times S squared times the height was 144, right? So we have to solve for S squared. So I would divide, well, let's see, 144 divided by 3, that's going to be 48, right? So we'd have this 2,226,450 equals 48 S squared. So then solve for S, we divide by 48. So we get S squared. What is that? 2 million number divided by 48. What do you get? S squared equals what?
47,217.
47,217?
Yeah, 17.771.
47,217.71. So then we do the square root of that, and that's going to give me S. You got a different number? Well, let's see what the work says. So we've got plug in, they multiply by 3 to divide. Okay, they got x squared equals 46,384 is what you should have gotten. And then you do the square root of that, 215. So our numbers were a little off. Use these. They did rather than multiply 144 by 1/3, they multiplied this by 3, and then divided by 144. Same result, just different order. All right, any questions on that example? All right. Okay, this one we have to use trig. To find the volume of the right cone. We need to find R. We have this right triangle. We know one leg is 16. We've got to find the other leg. Which trig function am I going to use to find R? It's the one that doesn't involve a hypotenuse. We don't have a hypotenuse. Hypotenuse is not in play here. Which one? Tan, yeah. Tan of 65 equals, what goes on top? The 16 or the R? 16, opposite over adjacent. So it would be 16 over R. So then R is going to equal 16 over tan is 65. That's a 65. All right, so then we get R equals, what does R equal? What? 7.46. All right? So then we do our volume formula. Volume equals 1/3 the area of the base, which is a circle, so it would be 1/3 pi r squared times h. We plug in. That equals 1/3 pi 7.46 squared times the height is 16. And then we solve. See what you get for the answer. Okay, you should get, let's see here, we can plug in. (932.45) feet squared. Feet cube. All right. Any questions? One more example. This is a composite. It means it involves two different polyhedrons. What could I split this into? Cube and a pyramid, right? So just calculate them separately. For volume, calculate their volume separately, then add them together. So we would have volume equals the volume of the cube plus the volume of the pyramid. So that's going to be side cubed for the cube and 1/3, and then the area of the base is a square, so it's side squared times h. So really all we need to do is plug in s. It's the same for all the dimensions. It's all 6, which makes it nice. Doesn't necessarily have to be 6. This could be 8 or 12 or whatever, but it's 6. So we plug in 6 for s, and we get our answer. 288. cubic meters. Questions? Everybody has it. All right. That's it.